Okay, listen carefully. We are on page 286. This is a short lesson. You will have time to get the assignment done if you stay with me. But go ahead again, page 286. Yes, ma'am.
So yesterday for the IM
Yes.
we did unit prices, and we never learned that. So that was just really confusing.
Yeah, okay, and I threw that in there, but unit price is a unit rate with money.
Oh.
Yeah, so all you have to do is you have to
I just kind of skipped it.
Yeah. Sorry, and we didn't talk about unit price exactly, but unit price is just X amount of dollars over 1 unit. One bottle, 1 can, 1 ounce, so that's all it was. But that's okay. All right, we're talking today about calculating percent of error. And yes, you've already done this. So this should be review.
Oh, percent error.
Yeah, Mr. Hubbard already taught us this, so we should just...
Yeah, we're good. We should just,
You should just give us our...
a field trip. We can give us rains to go to magic.
I'll give you more problems if you want it. I have no problem with that. I'll wait.
That's a funny joke, Mr. Red.
Okay. Really, yes, you've gone over this before, so it shouldn't be hard. It shouldn't be new, but we got to make sure we know that formula. Does anyone remember what it was? Yes, ma'am?
Is it actual or guess?
That's a great question. Yes and yes.
Well, but
So which one do you think it actually is? Not actually that, but
actual times the guess amount.
okay, you're getting there.
Measured, or whatever,
Measured value
times actual value times 100 minus.
What's the absolute value?
It's the absolute value.
excuse me.
Plus 2.
I mean that fraction bar. Okay. So yeah, it's the actual value minus the measured value. I mean the measured value minus the actual weight.
Absolutely.
You gotta make sense. You gotta make sure you realize that if this is absolute value, which it is, either number can come first. Either number comes first. It doesn't matter. But then over the actual, and that equals, or that's going to give you a decimal number, and to make it a percent, you multiply by 100. Okay, so that looks like a lot, but it's really not too much. Before we get into the actual uses of this, I think it's really cool what this guy did. So look on page 286, and this is Italian physicist, so he deals with physics, and yet he was able to come up with some piece of info, and his percent of error was very low. Italian physicist Enrico Fermi came up with a simple way to estimate Earth's circumference. Okay, so you guys understand Earth is a giant sphere, and there is a distance across it, and we actually know what it is now. Like, we've actually measured it, but think about how you would measure that. You wouldn't just get this giant ruler, or even what surveyors use, like laser measuring. You would actually have to travel around the Earth, and you'd have to make sure you travel in a way that you're going to get to the other side and back to your correct spot accurately. This guy, I don't know what year, I should have looked up the year, but I'm guessing it's in the 40s. He guessed the circumference of the Earth using a couple facts, and here are the facts he had. Bullet point number 1. It is about 3,000 miles from New York to Los Angeles. All right, we know that because they travel that all the time. It's about 3,000 miles from New York to Los Angeles. There are 4 time zones in the United States, if you're not counting Hawaii, because we're talking about continental United States, but you only have to cross through 3 of them when traveling coast to coast. That means, bullet point number 3, this is the most important info, which I was like, what? That's how you figure it out. Each one of the 24 time zones must be about 1,000 miles wide. So across the Earth, how many time zones are there according to that problem? There's 24 of them. And each one is how long?
1,000 miles.
1,000 miles, approximately. These are not exacts, but approximately 1,000. So how many thousand miles are around the Earth? 24. He estimated 24 because each time zone, how many time zones? 24 were how long? 1,000. So 24,000. That was his guess. That was his estimate. Now, I want to know if his estimate was accurate or not. And if so, how far? Now, the actual amount we're going to get, I'm going to put in this. So his estimate was 24,000 miles. So please write this down. The actual we found it to be, so we actually figured this out, was going to be 24,902 miles. How many miles off was he? 902. Now I'm thinking to myself, 902 miles. It's not that far, but it's like from here to. I think it's a little. Is it 900? Oh, cool, awesome. I'm not going to debate that because she says she knows that. So it's from here to Iowa. How long does that take, time-wise? About
14-ish hours.
14. Let's just go with 14 hours. So is that kind of a significant amount? That's significant. Like either travel 1 mile or 1 hour or 14 hours. That's a big difference. So he was pretty far off, right? But see, now if I say he's pretty far off because he went 902 miles off, you're like, well, you think that's a lot, but it might not be that much. That's why we use that percent of error, because there's a way to describe it mathematically, and then everyone can say, oh yeah, that is pretty far off, or wow, he's actually pretty close. Okay, so what I'm going to do is the percent of error. I'm going to put the numbers where they go and see how far off this guy was with his estimate. He did not measure it out. He used these pieces of info that we mentioned to figure this out. So absolute value of, what was it? Measured minus actual, right?
C.
Tell me if I wrote this correctly according to what I just said. All right, did I write everything like I just said?
Yes.
I said measured minus actual.
Yeah, I mean.
What did I do?
It's the absolute value. It's the same thing because there's the absolute.
How many of you would have put 24,000 minus 24,902? That's how you should have put it. But I switched it up. I'm so mixed up on these. 24,902 minus 24,902. What happens if you switched it? What did you get?
Negative
902. But yes, because it's an absolute value, you still end up with 902 over 24,902 times the 100. You still come up with the same thing, which is good, right? Because you don't always have to memorize it exactly. By the way, I'm going to give you a little confession time. You notice how we switched those around and we were okay with that? We were okay with that switching around. There are actually many times when you're getting a difference, when you're subtracting, where switching it around doesn't affect the answer. So do you guys remember y sub 2 minus y sub 1 over x sub 2 minus x sub 1? Do you remember that for slope? I could have said, I feel bad about this. Josh, I'm so sorry. Y sub 1 minus y sub 2 over x sub 1 minus x sub 2.
What?
And it's the same thing.
I don't. What's the difference? There's no.
That's a nice joke, Elizabeth. Oh, wow, that's so cool. Okay, yeah, you got funny guys in here. All right, anyway, I'll show you in just a moment. All right, I'm going to do 902 divided by 24,902. That's not it. 902 divided by 24,902. That gets me 0.0362219,902. Do you think that's the actual number?
Yeah, of course.
No. What I'm going to do is I'm going to multiply that by 100. I get 3.62219,902. And I don't want all that decimal place value. I'm going to put here is approximately 3.6%. 3.6% approximately. So how far was this guy off of the actual? 3.6, a little less than 4%. Hey, with what he used, those were the three facts. It wasn't like he came up with that. I'm like, whoa, that's pretty good. It's pretty good. All right, so that's the way we're going to measure it. Any questions on the process? Because I'm going to give you a couple hard ones. All right, here we go. Let's go with example number 1. This is where it gets a little bit tougher because you have to do a little bit more. Who can read for me? Yes, you may. Yeah, you can take out the Chromebooks again. Sorry if I closed it up and made you log out. Then you have to go back to Google Calculator. I feel kind of bad, kind of.
Yeah, you should still right. That was, no, I just have to use all my.
You have it.
Find the percent of error, and that's all we're finding. The relative error is very close, but I just want percent of error. Find the percent of error.
How do you show your work when you're
Let me show you exactly what I want. So this is what the problem gives me. It's 42.5 inches by 68 inches. So this is what they gave me. This is not what you have to write down necessarily.
Would you do it individually?
No, this one, again, let me just write it down and I'll show you what they're asking. Okay, they want you to find the percent of error of the area. Area always deals with two dimensions, length and width, base and height. So I'm looking at this right here. Did they give me two dimensions? Yeah, they gave me this by that. How do you find the area of this object? You have to do first 42.5 times 68. And you're like, how do you do that? You can put in your calculator. You can put 42.5 times 68. So Bella, this is where we're going to get that work shown. 42.5.
2,800.
I'm very slow at this, I feel. 68. You said 2,890? Okay, so you would have gotten 2,890 square inches. Square inches. When you have area, you must say square units. Square meters, square feet, square miles, square kilometers. That's for area. And we'll go over area more because that's... It's technically square inches. I know it says inches squared, but this is technically square inches. And you're like, what's the difference? I'm not going to get into that, what we call the semantics of the words, but it is a difference. And then what's 42 times 67.5? 2,835 square inches. Sorry? That's all right. Sorry, what did you say? You're getting there. Okay, let's get the percent of error. So we're going to take the actual or the measured. I'll go with the measured, so we're going to keep it consistent, minus the actual over the actual, and then multiply that by 100. So Bella, I need to see this, I need to see that, and that. And then just kind of work it out. So what's 2890 minus 2835? 55. All right. So I get 55 over 2835 times 100. And then all you have to do is 55 divided by the 2835, multiply it by 100. Sorry? I get approximately 1.9%. Approximately. 1.9400. But then you have to multiply that by
Yeah, but don't you just move the place? Oh.
2 to the, yeah, you move it 2 to the right. Or excuse me.
Calculator on our test.
Yep. Yes, you may.
What if we don't have a calculator?
Go get one.
Try to, no, because I don't always have access to Chromebooks. So try to get your own. I'll try to bring some too. But I need, sorry?
On the Chromebook, then you can calculate.
Oh, I see, yeah, yeah.
Like if there's.
So try to get one. Now, Does anyone have, can I see this one, Sydney? I think this is,
It doesn't have.
oh, does anyone have a sine, cosine, tangent,
Look at
scientific?
Annie's.
Yes.
I do. Mine does.
Did you just get this? Oh, this is a graphic. Yeah. Can I see it, please? Thank you. Oh, it's very nice. I even like the color. Okay, listen to me carefully. This calculator is a graphing calculator. So, listen. This graphing calculator is what you will need for high school. Okay, you will need this for high school. I'm not requiring you to get it for this class, but you can. So, like, if you decide that you're going to go ahead and spend, it's 120, 130, you can do that now and save it for the rest of high school and college. It works there. But if you're like, we don't want to make that investment right now, just get a scientific calculator. Does anyone have a scientific calculator? It's not this advanced.
I didn't.
No one.
I do, but it's
And again, you have it on the Chromebook, but you won't be able to have the Chromebook for tests or quizzes or even at home.
Don't list like Apple phones out.
Yeah, most phones. I got
Well, we
it.
can't use this.
Well, we can just bring.
No, don't use your phone. Yeah, don't use your phone. I mean, at home, you can use whatever you want, but here you got to use an actual calculator. Okay, but anyway, sorry. A scientific calculator has sine, cosine, and tangent. That sin, COS, and TAN button. If you have that, you're good. And they cost about $10. Yeah, and someone in the other class had 20. I was like,
Should get this
oh.
one.
Because you're going to get them on Amazon for $8. And then Walmart has it from $8. And then, I don't know about Office.
Target.
Target probably has it.
Staple.
Yeah, but you can get a $20 one. That's your decision. That's cool. Okay, let's do one more and then I'll let you go. On page 287, do number 1 on the try these. Find the percent of error on page 287. The measured dimensions, 16 meters by 11 meters.
How would you do that? Because
Yes.
it has, instead of doing just one measure.
Like it seems like you're doing 2.
Yeah.
Okay, here's what you have. You have the measured and you have the actual, right? Is that how they label it?
Mm-hmm.
And they want you to find the percent of error for the area. So what do I have to do with these two numbers first? I have to first multiply them together. So really I only have one number, 176, and then the other one is 191. Good, 0.16. Those are the numbers I'm trying to work with. So now put it into your formula. Don't do it with these individually. Does anyone have a question? Because I'm here to help. No questions, no answers. Okay. Anyway. Measured. So please remember, although the measured and actual don't have to be in the same spot, the actual must be on the bottom.
Approximately 7.9%.
Ooh, good, Braden. I like how he said approximately, and I like how he said, what'd you say, 7.9%?
Approximately 7.9%.
Because if you just say 7.9, you're like, what do you mean, 7.9 miles? No, we're talking about 7.9%. Sorry? No, and thankfully we get to use calculators, so hopefully it doesn't get too rough.
Why can't we just use calculators like anytime?
Oh, you can, and you do. And I hope you do it well.
Why can't we just use another
Sin.
What is sin?
It's a ratio. So I did that.
Let's go.
Sorry? Oh, that means E minus 56.
Error.
No, it's not an error. It's like something to the 56th power. That's huge. Or actually, was it negative 56? So something with a decimal and 55 zeros, then the number. Nope. Thank me now or later. Same people.
Same here.
Goodbye, swivel. Percent of error, low.